So welcome back to my YouTube channel. There's going to be some quadratic graphs on your assignment. You'll see something very pleasant like this one. Well, actually, it'll be a negative 8x. Now, when you do quadratic graphs, you're going to be told by just about every instructor that we're dealing with graphs that are of a U shape and they are symmetrical. You'll see some more business-like situations shortly where revenue can be expressed as a quadratic. All I really need you to focus on is finding the axis and the vertex and a few other points. There are some formulas you're going to be given. You'll find out the axis of symmetry is a spinoff of the quadratic formula. Now, what a lot of people don't realize is that A and B are coefficients of the standard form equation. So make sure you realize that A is actually the number in front of x squared, and B is the number in front of negative 8, or I mean in front of x. And you're going to use those values to arrive at the axis of symmetry. So after substituting values, that's going to give me a value of x equals 4. Now, what that's going to tell you is that this quadratic graph situation is going to have a line of symmetry at x equals 4, and that's a vertical line. And then you're going to be told to find the minimum value or the vertex, and I would know it as both. Now, later on, you're going to know graphs that have a maximum value. If you want to find the vertex, you have to evaluate the function at f of 4. You have to determine the y value there. So take f of 4, and then you need to plug in 4 for all your x's. Upon further review and upon putting it in the calculator, you're going to find out that that answer is negative 4. So in this quadratic situation, you're going to find out that the axis of symmetry is at 4 and the vertex is at negative 4. So now we know a little bit of information about the graph. So let's summarize what we have so far. If we actually put this on a coordinate plane formally, we'd actually know that the graph has a low point of 4 and negative 4. Now, we may be interested in more details of the graph. So going back to the original graph, you may be interested in the y-intercept. The y-intercept is f of 0. And you can plug in 0 for all the x's. Now, when you do that, you'll probably realize after about 2 or 3 repetitions that you're going to be left with just 12. So now you know that this quadratic graph sails through the point 0, 12 on the y-axis. Now, this graph is more illustrative. This isn't exactly accurate. But a lot of times in business, you just want to illustrate something. Maybe you're not terribly worried about being precise, but you just want to get your point across. Now, in the case of the x-intercept, if you need to find the x-intercept, you can set the equation equal to 0 and factor it. You will find out that the quadratic factors into binomial factors x minus 2 and x minus 6. Now, you'll find out that x equals 2 or x equals 6 on the quadratic equation. Sorry, I'm running out of room. But you can also determine that there are two x-intercepts. Now, I wouldn't advise you to find the x-intercept every time. There's going to be situations where your quadratic isn't factorable and it might be a little impractical or unnecessary to find the x-intercept. But that's all you really need to know. Now, right off the bat, now we all of a sudden have a lot of quadratic graph to graph. Now, here's a mystery point, and I'm going to leave this up to you. But you're going to find out upon a lot of reflection that that point is 812, and you can get that without any algebra. But really, think about how and why, and think about the whole symmetry of everything, why that point is 8,12. Now, that is pretty much what you have to do to figure out most quadratic graphs. I was concerned about some situations, however, on MATLAB. Like you were told, we know the vertex is 4, 4, or 4, negative 4. There's what's called a vertex form of that graph. I'll just tell you, it's going to look like this particular situation. And HK is vertex. Now, based on what we found about the vertex from what we did previously, you can determine that it's x minus 4 squared minus 4, because that's what MATLAB is going to want you to put in. Now, A, there was no term in front of A, so the answer to that was 1, so we don't worry about a number in front. So this is actually another form of the vertex equation. I'll make sure to point that out as well in the lesson. Thank you once again for tuning in.